At the bottom of the ocean, there are places where the seafloor appears to open into another body of water. It has a visible surface. It can have shorelines. And from the perspective of a deep-sea submersible, it can look remarkably like a lake sitting on the seafloor. But there is something deeply strange about it. The lake isn't surrounded by land in the way a normal lake is. Its surroundings are the ocean itself. And the water inside, it is still water. So why doesn't the lake simply mix into the ocean around it? The answer begins with something surprisingly simple. Density. Seawater is already denser than freshwater because it contains dissolved salts. But in these deep-sea pools, the water can become extraordinarily salty. That extra salt increases its density. And when two fluids meet, gravity naturally pushes the denser fluid downward, while the less dense fluid remains above it. So the concentrated brine settles into the lowest parts of the seafloor. That is the first piece of the answer. But density alone doesn't explain why these lakes can persist. Because if the brine and seawater are touching, they should still exchange molecules. The ocean is constantly moving. Currents pass above the pool. Water circulates around its edges. And the boundary between the two fluids is not a wall. So the real mystery is not simply why the brine sinks. It is why the difference can survive for so long. And that takes us deeper into what is actually happening at the boundary between the two waters. The deeper we look, the stranger the boundary becomes. The brine isn't just sitting motionless at the bottom like water inside a container. It is part of a physical and chemical system. Because it contains such a high concentration of dissolved salts and other substances, its density can be dramatically greater than the seawater above it. Less dense seawater stays above. Denser brine stays below. And that difference makes large-scale mixing much harder. But the boundary isn't a wall. The two waters are still exchanging material. They're just not mixing quickly enough to erase the difference. That slow exchange matters, because the chemistry inside the brine can become very different from the seawater above it. In many deep-sea brine pools, exchange with oxygen-rich seawater is limited enough that the deepest parts can become severely oxygen-depleted or even completely anoxic. The result is an environment with chemical conditions very different from the ocean immediately above it. So this is no longer just a strange example of water being heavy. The brine has created a distinct chemical environment beneath the ocean. And that gives us another clue. The pool isn't simply a quantity of salty water that sank once and has remained untouched ever since. Something is happening continuously. Material is moving in. Material is moving out. And yet the pool remains. So if the ocean is slowly mixing with the brine, what keeps the lake from disappearing? If the brine were just heavier seawater, we could stop at density. But that wouldn't explain the persistence of these pools. So why doesn't the brine eventually disappear? Part of the answer is that the brine can be replenished. In some locations, highly saline water forms or is released through processes involving salt deposits beneath the seafloor. That concentrated water can move into depressions on the ocean floor. Because it is denser than the surrounding seawater, gravity pulls it downward and helps it remain concentrated in those low areas. At the same time, some of the brine slowly mixes or diffuses into the surrounding ocean. So the pool isn't a trapped sample of ancient seawater that somehow survived unchanged. It can be an active system. Concentrated water enters. Some material slowly leaves. And the difference in density helps keep the brine concentrated at the bottom. But this creates another problem. If new brine keeps arriving, and the seafloor depression is already filled. What keeps the pool from eventually overflowing? The answer is not that nothing escapes. Something does. The system can lose material across the boundary while receiving new dense fluid from below or nearby. The result is a balance, and that balance is what allows something that looks like a separate lake to remain beneath an ocean that is constantly moving above it. Eventually, the strange behavior starts to make sense. The pool can reach what scientists call a dynamic equilibrium. Brine enters. Some slowly mixes away. The seafloor keeps the densest water concentrated in the lowest parts of the basin. And gravity continuously works against large-scale overturning. That does not mean the pool is perfectly still. It isn't. The boundary can shift. Currents can disturb it. Chemical gradients can change. Small amounts of brine can move into the surrounding seawater. But the overall structure can remain stable because the forces and flows are balanced. Think of it less like a sealed container and more like a continuously maintained landscape. Water is moving through the system, but the pattern remains. The dense fluid stays low. The lighter seawater stays above. And the transition between them can remain remarkably sharp. This is why the pool can look almost impossible from the viewpoint of a submersible. A vehicle can travel through ordinary seawater and suddenly encounter a distinct interface. Below that interface is not another solid surface. It is another fluid. Yet the difference in density and chemistry can be large enough for the two environments to remain visibly separated. The ocean has not stopped mixing. It has simply reached a situation where mixing is too slow to erase the structure. And now the original mystery has a much more precise answer. The lake exists because the seafloor provides the shape. The concentrated salts provide the density difference, gravity keeps the densest water below, and a continuing supply of brine can maintain the system as some of it slowly mixes away. So how can a lake exist inside the ocean without mixing? Because it isn't truly isolated from the ocean. It is separated by physics. There is no wall beneath the ocean.
Final reveal.
No
What looks
membrane.
impossible becomes understandable
No hidden
once.
container.
The strange truth.
Just two connected fluids, arranged according to their density. The brine is so much denser than the seawater around it that gravity keeps it pooled in the lowest parts of the seafloor. At the same time, the boundary between the two fluids is not perfectly sealed. They slowly exchange material. New dense fluid can enter. Some brine can gradually mix away. And the system can remain stable as long as those processes maintain the overall balance. That is what makes these places so strange. From above, the ocean looks like one continuous body of water. But at the seafloor, differences in density and chemistry can create something that behaves almost like another world. A surface, a boundary, a basin, and a fluid environment that can persist inside the ocean without ever being completely separated from it. The lake isn't breaking the rules of physics. It is revealing them. What looks impossible at first becomes understandable once you see the forces underneath. And that is the strange truth beneath the ocean. Sometimes water doesn't behave like one world. It can behave like two different worlds.